Partha, good morning. Yes, we can hear you.
Okay, good morning. So we continue with our lesson. Let me share the screen. Okay, yesterday we stopped at the theories of magnetism. Okay, so make sure you remember all the theory. Okay, for this topic, usually theory is half the mark, and the rest is the calculation. Okay, so let's us recall back what we have learned yesterday. So you have learned about the flux, okay, and the unit is Weber. And then of course you learn about flux density. The equation is flux divided by the area. Okay, the unit is Tesla. Okay, the unit. Okay, this is the unit. And of course you learn about what else? Oh, permeability. Mu equals to mu naught mu r. Make sure you find this in your calculator. Okay, for EX Casio FX 570 EX. Okay, that one is you just press shift 7 and constant. Okay, so this one has unit, this one has unit, this one is just a constant, no unit for this. So make sure you remember this. Okay, this is just a relative. Okay, and for relativity, okay, unity equals to 1. Okay, this one is for air or free space or insulator. Okay, insulators such as plastic and wood. Okay, for metal, okay, for metal it can be 1, okay, and sometimes it can be 100 to 1000. Okay, X. Okay. So depending on the material, this one is called ferromagnetic material, and this one is just a conductor, usually a conductor. So for this case, you usually will be given, but for this case, make sure you know. Okay, this one always 1. And then you learn about what else? Let me check back. Okay, reluctant. So reluctant use S, the length divided by mu. Okay, mu is this one. Okay, and then multiply by area. Divide by area. So the unit is AT divided by Weber. Okay, so you learn about this one, and then you learn about magnetomotive force. F is equals to flux divided by the reluctant. Okay, so basically it's almost the same, right, for electrical. Okay, so this one is V is equals to I. Oh, sorry, this one is wrong. Yes, okay, multiply by R is related. Okay, so make sure you know the relationship because it is use the same concept. Okay, then you learn about the circuitry analogy. Okay, this one will be our focus today. Okay, and of course you don't forget the magnetizing force. Okay, or magnetomotive force. Okay, this one. So hash is equals to F divided by L, and also hash is B divided by mu. So make sure you know this relationship. Okay, magnetization force. Okay, and don't forget about this. Okay, this one I already explained. And make sure you know the saturation. So you have B hash curve. Okay, most material will have saturation point. And when you increase the hash, you cannot increase the B anymore. So that is the saturation point. This only apply if you're at this point. Okay. So at this point, okay, if you're already saturated, this law is not applicable. Okay, and then you learn about the Ampere's law. Okay, make sure you understand this. And then magnetic, okay, induced magnetic, okay, and where is it? Okay, and the magnetic leakage fringe effect. Okay, make sure you remember that back. And now we focus on the magnetic circuit. Okay, before I forget, this one also, F is equals to flux S, okay, and also equals to hash length. Okay, so this one, okay. So sometimes we can use the reluctant, or sometimes we can use the magnetizing force. Okay. Okay, now we refresh back. We continue with our lesson, which is magnetic circuit. So as I mentioned before, it's almost like electrical circuit. So you have the source here. We usually indicate the voltage source as E, okay, electromotive force. So you have flux equals to current and reluctant equals to resistance. So it's almost the same. So you can apply the knowledge in your electrical in your magnetic circuit. So this is the comparison. You can see it. Okay, the current with the flux, the current density with the B. Okay, this one I think is not your focus. Okay, hash and E. F is E. Okay, I think this one is not the same. Okay, make sure you repair this. Okay, and permittivity for electrical permittivity. Okay, and reluctant is the resistance. Okay, now we focus on a series circuit, a simple circuit. Okay, for something like this, okay, you can see here, this is the circuit. Okay, you have, let me draw. Okay, so you have a core here, something like this, with the air gap. This is the air gap. Okay, so you have a winding here. Okay, so you have current I, and then this one is the number of winding. Okay, and the length. Okay, so this one is called a effective length or effective length. So basically you have to take the length at the center. So you have to take the length at the center. Okay, if you want to measure the core, if you have the measurement, make sure you take at the center. Okay. So you have the length is the L core, length of the core. Okay. And then for this one is the length of the gap. Okay. And then if this, okay, this one I don't draw it properly. Okay, if the area is the same, okay, make sure this is the flux. Okay, the flux, and the area must be perpendicular to the flux. So this one is AC. Okay. Okay, if you have different area, make sure you have AC1, AC2, AC. This one also length C1, length C2, length C3. If you have different area and length, okay, you have to divide it. But if you have the same area, you can just lump sum it up. Okay, you just sum it up directly. So how to calculate this? Okay, remember you have, when you do the electrical part, you have to find the resistance first, and then you can get the current. Okay. So if you look here, this one you have a core here. Okay, you have the core. Okay, SC is the reluctant for the core, and SG is the reluctant for the gap. Okay. So you have the Ni is the magnetomotive force. F is equal to Ni. Okay, and you have the flux, which is the current. Okay, so remember back the formula. LC is divided by mu mu C A C. Okay, so mu C is mu not multiplied by mu RC. Okay, relative value. So this one usually will be given. Okay, so SG also the same, but mu RG is basically 1 because it is a gap. Okay, so the same formula here, SG is equals to LG, length of the gap, divided by the mu naught, okay, A gap. So if there is no fringing effect, A gap is the same as the core. So let me remind you again. So if there is no fringing here, remember that I said fringing. Okay, if there is no fringing, okay, the area here, the area A gap is the same. AC is equals to AG. Okay, area of the core is equals to area of the gap. But if there is a fringing here, something like this, okay, fringing, AG will be larger. But for your level, we will not consider, usually we not consider the fringing effect. Okay, and then after you obtain the S, okay, because this is a series, so remember, so use this formula, F is equals to flux S total. So the S total, because this is a series, you just sum it up, S gap plus S core. Okay, so that is the relationship if you use reluctant. Okay, if you don't use reluctant, you can use hash magnetizing force. Okay, so magnetizing force, if you use this, okay, you just do a loop here, you can see here. Okay, at the core here, instead of using reluctant and flux, you use Ni equals to, okay, hash core, okay, magnetizing force at core and the length of the core plus hash GLG. Okay, so either you have this information or this information. So depending on the information you obtain, okay, either you have to calculate the reluctant. If you have the permeability, you can use the reluctant here. You have the dimension, you can use this. But if you have the magnetizing force, okay, or the hash, okay, if you have hash, you have to use this method. So basically just sum it up. Okay, so this one is Ni, this one is hash C, LC, and this one is hash HG, LG. Okay, or you can use the flux. This one is C, right? Okay, flux SG flux S as G. Okay, this one is SC. Okay, so either two way. So make sure you know where to use this. Okay, so this is how you solve a series magnetic circuit with air gap. Okay, how about multiple composition? Okay, you can see here you have multiple composition. Okay, so you have iron, you have steel, and cobalt. Okay, and it is all in a series. So almost the same, but instead of just use ST, you have 3. So L iron divided by mu iron and area iron. Okay, and plus L steel divided by mu steel area steel, and then L cobalt divided by mu cobalt, permeability of the cobalt, and the area of the cobalt. So you have to do all of this. Okay, so it's almost the same. So if the question asks you to draw the analog of the circuit, make sure you know how to draw this. So for the F, you just put F, if it's in series and 3 component, you have to put all of the component. Okay, so this one is S steel. Okay, S. This one is iron. S steel. S cobalt. Okay, and make sure don't forget to flux. Okay, that is how you do it. Okay, so the same concept. Okay, F is equals to flux S total. Okay, and you can get either, they usually give this one, you have to find the flux. Okay, or it can be another way around. If they give flux, you have to find the current. Okay, so this one I already show you. So basically it's something like this. And of course, if you don't have the information to calculate the reluctance, you can use H steel, L steel, H. Okay, H. Okay, this one is iron, right? IRON. Okay. H iron, steel, L steel, and this one is H. Okay, H cobalt, L cobalt. Okay, if they give hash, you can use hash. Okay, so F is equals to hash A LA plus hash B LB plus hash C LC. Okay, so either you can use reluctant or you can use magnetic force. Okay, so we start with an example here, a simple example. So you can see. Okay, you can see the first example here. Okay, I suggest you, when you answer this, okay, you list down everything. Okay, so find the value of I needed to develop magnetic flux of 4 multiplied by 10 negative 4 Weber. Okay, so find I. Okay, so flux 4 multiplied by 10 negative 4. Okay, so the permeability is, okay, if you can see here, this has unit. Okay, when it has unit is mu. Okay, if there is no unit, it is mu r. Okay, be careful. And mu r usually 100 to 1000. Okay, mu usually milli. Okay, milli to micro. Okay, so mu 1.818 multiplied by 10 negative 3. Okay, and also find flux density. So they want you to find I and B. Okay, so also information here, UN is equals to 400. Okay, area is 2 multiplied by 10 negative 3 meters squared. Okay, and the length here is 0.16 meter. So find I. Okay, so you have flux. Okay, you have to calculate. Okay, there is no. Okay, wait. So to do this, you have to calculate the reluctance first. So S is equals to L divided by area mu. So use your calculator. Okay, make sure you practice because the number is either very small or very large. So 0.16 is 0.16 divided by the area is 2 negative 3. Okay, and divide by, where is the mu? Okay, 1.818 negative 3. So you get 4404.4. Okay, so you get the reluctance is 4404.4, and then you have to find the current. So F, remember, equals to Ni, equals to flux S. So I is equals to flux S divided by N. So flux is, where is it? Okay. So 4 multiplied by 10, negative 4, multiplied by 4404.4. Okay, this one. Okay, and then the number of turn is 400. Okay, so multiply by 4 divided by 400. So the current need for this is 0.044 ampere. Okay, so that is how you calculate the parameter. Okay, and then you already obtained the current, and now you have to find B. Okay, they ask you to find flux density. Okay, so flux density is B, and B is equals to flux divided by A. Okay, so flux divided by A is, flux is 0.044. Okay, divided by the area is 2 multiplied by 10 power negative 3. Okay, the answer is not the same. Okay, where is the mistake is made? Can you see it? Okay, are you seeing where is the mistake? Okay, you have to check back. Okay, any of you see the mistake?
Cannot, doctor.
Okay, it's okay. Let me check first. Okay, I have this one. Okay. Flux is 4. Okay, already checked. The answer should be something like this. Okay. Oh, this one is flux. Sorry. Flux is this one. Okay. So this one is the current. Okay, make sure you be careful. So this one is current. So flux is 4 multiplied by 10 negative 4 divided by 2 multiplied by 10 negative 3. Okay. So you will get this answer 0.2 Tesla. Okay. And if they ask you to find the hash, okay, you can just divide it something like this. Okay. So this is the type of question they will ask you. Okay. So I give you another, okay, they already show you here. Okay, now we move on to example 2. Okay, for example 2, you can see here, find the flux if the flux density is 1. So you just extract all the information first, okay? So find flux, okay, if the B is 1, okay? And then find current, okay, and then find the magnetic field strength, okay? Magnetic field strength is hash, okay, in the A gap, okay, and the hash in the core. Okay, so also they give you mu r, so 70,000. So there is no unit for mu r, so be careful. And the area is 9 multiplied by 10 negative 4 meter squared. Okay, make sure the unit is in meter. If they give you in cm, you have to change it to meter. Okay, cm, mm, you have to change it. So L is equal to 0.3 meter. So make sure this one. Make sure in meter in the SI unit. So what to do first? So you want to find the flux first. So you have the turn, you don't have the current, okay? So you have the length, So you can see here, this is the step to do this. Okay, flux is equals to BA. So you already have the flux density is 1 Tesla. Okay, and the area is also given, and assume that there is no fringing effect. Okay, the area is stay the same. So what you have to do is first, okay, so remember the B equals to flux divided by A. So to calculate flux is just equals to flux is equal to BA. So B is 1, okay, and the area for this is 9 multiplied by 10, negative 4. So you get the answer is 9 multiplied by 10, negative 4 Weber. Okay. So that is how you find the flux. Okay, next. Okay, after you find the flux, the question asks you to find I. Okay. So I is, okay, remember F is equals to Ni equals to flux R. Okay. Flux S, sorry, reluctant. Okay. So now you already have the flux. Okay. You already have this one. You want to find this one. The next step is to find the S. Okay, reluctant. So S is equals to, because this is in series, you can see here the flux is only one path. So this is in series. So S is equals to L core divided by mu not mu core R core. Okay, mu not R core plus multiply divide by area of the core, and then plus the length of the gap divided by mu not, and mu R for the gap empty space is gap and a gap. Okay, so you have to calculate this. Okay, and then where is it? Okay, so you have to use this. The length, where is the length? Okay, so the length is 0.3 divided by mu naught. Okay, relative permeability. The relative permeability is 30,000, right? Okay, 70,000. Sorry. So 70,000. Okay, 70K. Okay, and the area of the core is 9 multiplied by 10 negative 4. Okay, so and this one is the length is 0.0005. Okay, very small, but okay, mu naught and mu R is 1. Okay, remember empty space is 1 and the area is the same, 9 multiplied by 10 negative 4. So this is your reluctant. Okay, total reluctant, ST. Okay. Okay, this is the circuit analogy if you want to draw it, because you have the core and you have the gap. Okay, so this is the way to do this. Okay, if you want to do it separately first, you can. Okay, and okay, let me see. Okay, this one. Oh, for this case, they use separately. Okay, they find the FG first because you have the flux, right? So no problem for this, also can. But if you already find the F total, also can. Okay, let me calculate this first. Okay, use your calculator, practice it. So S total will be 3789.4. Okay, So F is equals to flux multiplied by S total. So flux, remember what is the flux? Okay, let me check. Flux. Okay, flux is 9 multiplied by 10, negative 4. Okay, and this one is 3789.4. So one thing you have to look here, you can see here, the reluctance for the core is much higher than the air gap. Okay, the reluctance for the air gap is much more higher than the core. Okay, so reluctance, okay, the resistivity, okay, in the core, in the gap is much more higher. So make sure you know that characteristic. Okay, this one can be useful. Okay, so oh sorry, this one is wrong. So 445,789.4. Okay. So ampere turn divided by Weber. Okay. So this one multiplied by this one. Okay. So multiply by 9. Okay. So you get the F is equals to 401. Okay. 0.21. Okay. And what is the question again? They ask you to find the current, right? So remember F is equals to Ni equals to this one, okay, and then I is just divided by F divided by N. So 401.21 divided by number of turn is 500. So you get 0.8 ampere. Okay. So that is how you solve this question. Okay. And next part is find the magnetic strength, magnetic field strength, which is hash. Okay. So hash is just B divided by mu naught mu R. So remember B is already given, is 1. Okay. If they don't mention where is the location, means that B is the same for both location. Okay. B at the core and B at the gap is the same. Okay. Only the mu is the different one. Okay. So you can calculate it using this method. Okay. We take a break. We will start again at 11:45. Okay. So for now, check in your attendance.